Another type of continuous probability distribution is the normal distribution. This is the one that is used throughout all inferential statistics and pretty much the basis of everything else we'll be doing from this class on. So a normal distribution means that we have the mean right here in the middle. Most of the information, most of the probability, the highest chance of things happening is between one standard deviation above and below. In fact, if it is a true normal distribution, about 68% of all outcomes are between 1 and -1 standard deviation from the mean. 95% fall within 2 standard deviations of the mean, and 99% fall within 3 standard deviations of the mean. The parameters in this case is not a high and low. It is a population mean and a population standard deviation. So our parameters are where does it fall compared to the mean in standard deviations. Our probability distribution function, it looks really awful, but don't worry, Excel does it for us. And our range in this case is -infinity to +infinity. So even though it gets really, really close to the axis, it never actually touches. The mean and standard deviation give the shape of the curve, so it can be really peaked, it can be more bell-shaped, it can be a little bit more flat. The high point is the mean and median. Those should be pretty much the same number. And of course, the area is still the probability. So when we're finding probabilities, the easiest way to do it is to draw a picture. So you draw a curve, and then you write a line somewhere in there, and then you figure out which side are you trying to understand. When we go to Excel, this is norm.dist, and then it asks for 4 things. So it asks for x, which is going to be the point that you are interested in, that outcome. Then it's going to ask you for mu, which is our population mean, sigma, our population standard deviation, and a 1, indicating that it is a cumulative distribution. So we're going to look at these 3 examples, and then I'll give you some time to practice, and then we'll talk about one other cool thing that this will do. So let's go here. So if mu is 20, so the population mean is 20, and standard deviation is 3, so sigma is 3. First thing is, what is the probability asking you? So in this case, it says x is less than 17. So if we draw a picture of that, if we have our curve and we have 17, it is asking, what is the probability? Oh, that's not what I want. On this side right here, that is what we were looking for. This side right over here. Try that again. So it is asking us for this value, this area right in here underneath 17. The norm equals norm.dist assumes that it is asking up to that point. So whatever point you're looking at, 17 and below, that is how this function is set up. So norm.dist, it tells you that it wants 4 things. The first one is x, in this case is 17. Then it is asking you for the mean and the standard deviation for the population, as well as asking, is it cumulative, which we say yes, so we put in a 1. So the probability is roughly 16% for up to 17. If we want to look above 17, which is what this one's asking, so going back over here, we are now saying, what is the area above whatever point we are looking at, which is 17, not 22, sorry. So going back to here, we know that the area underneath the entire curve is 1. So I can take 1 minus norm.dist, and again, putting in all of the pieces. And that gives me about an 84% chance of this part occurring. So we can take the whole curve and say this part, or we can say 1 minus this part and get the other side, if that's what we're interested in. We can also look at the area between 2 points. So if we were looking here, I would say, nope, let's go back, sorry. If I look at the area of 22, Excel is going to give me this tail and this thing. It's going to give me everything up to 22. So I can take the norm.dist of this one minus the norm.dist of 17, which is going to give me up to here, which is this part of the tail which we don't need. So we're essentially going to subtract out this part and we'll be left with the middle. So again, it'll be norm.dist, in this case 22, plug in all the other values, minus norm.dist of 17, plug in our other values. Say okay, and so the area under the curve between 17 and 22 is roughly 58.9. So take a minute, and I want you to pause the video, go into Excel, and try working with these three with norm.dist. When you are done with that, we can also ask the question the other way. So instead of what value gives a probability, we can ask it the other way. So we were saying at 17, what's the probability of this happening? If instead I have a probability and I want to know what value falls there, I can use an inverse function. So this is now asking for probability inside of it, so I'd put a probability here, and it would give me the value that would fall at that probability. So instead of saying 17, what's the probability here, I would say the probability of 0.5, what value falls there? And it would hopefully tell me 17 or whichever. So if I'm assuming the following, the same thing that we were doing, so 20 and 3, what would be the probability, what value falls there, of being less than 0.6? So the probability of 0.6, what value falls there in the curve? So I'd go back to Excel. In this case, it is norm.inv. It's asking me for the probability, which is 0.6. We're using the same mean and standard deviation. And that is telling me that roughly 20, a little bit more, so roughly 2021 is the value that falls at that point. So instead of 22, this would be 20.67.